Hello everyone. The concept that we're going to have a look at today is called discretization. So what is discretization? Why do we do this? And how do we do this is what we're going to have a look at today. Right? So before you understand what discretization is, you need to understand what the difference between continuous and discrete data is. Right? So looking at the definition of continuous data, you can say, so these are variables that can take up infinite number of possible values within a given range, right? What I mean to say is that they are not restricted by being any integer or whole numbers or whatever. They can take up, theoretically speaking, infinite number of options. For example, think about something like height, right? Someone can be 160 centimeter, they can be 160.5 centimeter if you are very precise with the measuring, right? They can be some 161.6 centimeter or whatever. So I believe you get the point, right? This is a feature that can, practically speaking, take up infinite number of options, right? Same goes with weight as well. Depending on how you're measuring it, this also can take up infinite number of options, right? Temperature, time, all of these are examples of continuous data. So if that is the case, what do you think is discrete data? So discrete data, going by the definition of continuous, we'll understand that these are the kind of variables which can take up only a finite set of values, right? Think of something like the number that comes up when you roll a dice, right? They can be only 1, 2, 3, 4, 5, 6, right? If you are, for example, categorizing someone as an adult, a minor, or a senior citizen, or whatever, this also is me limiting the options that this variable can take up, right? So discrete data is something that is limited by the options that it can take up. That is the difference between continuous and discrete data. So discretization is the process of converting a continuous data to a discrete data, right? Why do we do this? There are a different range of reasons why discretization is important. There are certain algorithms which work better with discrete data than it does with continuous data. For example, decision trees. If you have learned about decision trees, you know that it makes split based on certain conditions, right? So if it is making splits based on a continuous variable, right, it would have to, for example, let's say I have something like age, right? I have 22, 23, 24, 25, and so on. So in order to figure out what is the best split, my decision tree algorithm will have to create these many splits and compare the information gain or Gini index or whatever is the uh, parameter over there, right? On the other hand, if I was creating this to be a discrete kind of a data, right, it could be something like adults, minors, and senior citizens. In this case, the number of splits and the computation complexity of this algorithm is greatly reduced, right? It only needs to make splits based on these categories or discrete categories over here, right? So that is one reason. There are certain algorithms, especially certain algorithms like decision trees, which works better with discrete data than it does with continuous data, right? So that results in faster computation as well, right? And also better interpretability, right? So the moment I have, let's say, age feature that's just like before, and I have a set of ages over here, if I categorize that into this kind of categories, and look at the frequencies, for example, right? I might be able to see that I have about 10 adults and 5 minors and 10 senior citizens or whatever. This also improves the interpretability of the data, right? Another thing is dealing with the noise or the outliers. The moment you convert a continuous data into a categorical data, it greatly reduces the effect of outliers over here. For example, you might have temperatures in the range, let's say 0, 10, 15, and for some reason you have an outlier over here, which is about, let's say, 60 degrees Celsius or something, right? If you are converting this kind of a feature to a category or a discrete kind of a feature, you might have categories like low temperature, medium temperature, high temperature, right? And then let's say you might say that 0 and 10 over here comes into the low temperature category, 15 comes into the medium category, and 60 and anything above is going to come into this high category, right? So that is the effect of this outlier. Have you been treating this as a continuous data would have been quite evident, right? It would have actually uh, created biases in your machine learning algorithms as well, right? So that problem is dealt quite nicely when you are converting this to a category, right? And there are many more reasons as well, depending on the context, depending on the problem that you're facing. Discretization might help you in this manner. So how do we do discretization? So this is not an exhaustive list, right? But these are the few most common types or popular types of discretization methods, starting off with something called equal width binning. Okay. So let me put up sample data over here of ages, let's say. Again, I have someone who is 20, 21, 22, 25. I have someone is 30 or 40, and then I have a couple of 50, 55, and 60. And then I have these people as well. Okay. So what equal width binning does for you, as the name suggests, you are going to create bins of equal width. What I mean by that is, let's say my first bin is starting from 20 and going all the way to 30. Okay. So this is my first bin, right? And let's say 31 to 40 is another bin. 41 to 50 is another bin. 50 to 60, 60 to 70, 70 to 80, and 80 to 90, right? You can also alter the width over here as well. You can create a width of 20. For example, I can say 20 to 40, right? I can say something like 41 to 60. You can say something like 61 to 80, 81 to 100, right? So I have these 4 bins. You can alter the width of the bin according to your requirement, right? If you want to have a look at a more granular sense of data, then you might want to increase the number of bins, right? But let's say this is the bin that we are working with, right? So what happens is anyone who is from 20 to 40 years of age is going to be put into this bin, right? So we have 1, 2, 3, 4, 5, and 6, right? So we have 6 members in this. And from 41 to 60 range, I have 1, 2, 3, 4 over here. 61 to 80. Actually, I have only 3 over here, not 4. 61 to 80, I have just 1. And 81 to 100, I have 3. Right? This is what equal width binning is going to look like. You are creating bins which are of equal width, and then you are assigning the bins to each of the continuous data over here, right? So that is one way of creating discrete feature out of your continuous feature. Something else is called equal frequency binning. Right? So one issue that you can see with equal width binning is that the frequency of the members in each bin is quite different. Right? We have 5 over here, 3 over here, 1, 3. So equal frequency binning is focused on one thing, that it is going to create bins which has equal number of members. That is, say over here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 members over here. Let's say I want to create 4 bins, right? If this is the case, I will first arrange the entire thing into an ascending or descending order, right? And since this is 12, 12 divided by 4 is going to give you 3. So each of these bins are supposed to have 3 members. So the first 3 members are going to come over here. So 20, 21, 22. So the width of this particular bin becomes 20 all the way to 22, right? And the next 3 members, that is 25, 30, and 40. Right? So the width of this bin becomes 25 to 40, and then 50, 55, 66. So the width over here becomes 60, 50 to 66. And finally, 90 to 97 is going to be this. Right? So over here, we have achieved one thing, that each of the bins have equal number of members, but you would see we have disruption when it comes to the width of the bin now. Previously, we had equal width. In this case, we have equal frequency. Now, this is also one of the methods of doing discretization, right? And then you have clustering based binning as well, which uses advanced clustering machine learning algorithms in order to figure out that which particular category is this particular continuous data supposed to fall into, right? And then create the bins out of that. And also we have the concept of custom binning. Custom binning is referring to the situation where you as the researcher or you as the data scientist, owing to your domain knowledge, owing to your domain expertise, owing to your business knowledge and everything, you are able to figure out that what is supposed to be the bin length, right? So rather than relying upon equal width or relying upon frequency or whatever, you are creating your own bins based on your domain knowledge. For example, I can say that anyone who is 0 to 18 should be considered as a minor, right? And then I have anyone who is between the age of 18 to 60 to be an adult, and 60 and greater to be a senior citizen, right? So in this case, the width of the binning of the bins is something that I have created customly, right? So that is also one of the method. Now mind that this is not an exhaustive list. This is not the only set of binning or discretization methods that you have in hand. There are more, and we will be covering those as well going forward. So stay tuned and see you in the next video. Thank you.